Want to nail engineering manager interviews at Mang and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into Mang. You could be next. To learn more, register for our free webinar.
Just to start off, I guess this is a interview on recursions. So it's going to be a programming interview in whatever language of your choice, focused on that topic. So it'll be about a 50-minute interview, after which time I'll have a little bit of time to, to give you some initial feedback, as well as for you to ask me any questions you have. And before we start, if you're not already in there, would you mind hopping into the code bunk that's in the provided link in the invite?
Okay, I'm in there.
Awesome. Sounds great. In that case, feel free to select whatever language you want in the top left. And yeah, I'll just do a little bit more prefacing before I paste in the prompt. So in a couple seconds, I'll go ahead and paste in the prompt for you. You'll be able to work on that for the entirety of the allotted time. Feel free at any point to ask me any questions you have about it, and as much as possible, try to work me through your solution, both to help you make progress through the question, as well as to inform me where you're at and know when it might be helpful to step in. And beyond that, if you've seen the question before, feel free to call that out, and I would be more than happy to provide you with another question.
Sounds good.
Awesome. So with all that said, I'll go ahead and paste it in. Oh, give me 1 second, actually. I'm just going to... The question does have an image attached as part of the prompt, so please let me know if you have any issues accessing it. I'm going to go ahead and create a fresh link for it right now, just so we don't have any issues with that. But in 1 second, all right, that should work fine. Cool. So without further ado, I'll go ahead and paste in, and I'll just put it as a doc string here. All right. As I said, you have a little less than 50 minutes. Best of luck.
Okay, I'm going to take a look at that image. All right, can you see my screen?
Yep, I can indeed.
Oh, come on. All right, given n non-negative integers representing an elevation map where the width of each bar is 1, can you compute how much water it can trap after raining? So uh, 0, 1, 0, 2, 1, 1, 0, 2, 1. So basically we're trying to see how many blocks of water we can store.
Yep, I think that's an accurate description.
This is definitely an interesting problem that I have not seen before.
Happy to hear it. That's definitely the goal.
Okay, so sorry, I'm just thinking for a second of how to start breaking this down.
No worries. Happy to give you a minute to think it over. Also happy to contribute more if you have any particular thoughts.
Okay, give me 1 second first to just try and work through it a little bit, and then if I get stuck, I might ask for help.
Absolutely.
Okay. So I guess the first thing that we're going to look for is we're going to want to iterate through our numbers. And we're looking for cases where we have a small number in between two numbers that are larger. So we've got a 1, a 0, and a 2. And in that case, we only store 1 unit of water. and that accounts for one case. And then this next one, we've got a 2, and then a 1, and then a 0, and then a 1, and a 3. And so how do we figure out what's between those? We've got 2, and we're going to have it filled in from the 2 to the 3. So we've got 1 unit at the bottom and 3 units between those. Or maybe I should look at it in layers. So,
I think this thought process makes sense so far.
okay. So, oops. Sorry, this initial part of getting an idea into words can sometimes be hard.
No worries at all. I'll let you in on the fact that this, you could easily be, working on this for another 20 minutes, 25 minutes. I would like completely step in and say we have to jump to coding right now.
Okay. All
Spending
right.
time on the design phase is totally normal and expected.
Good to hear. So, non-negative. So it's going to be 0 or more. Elevation map, where the width of each bar is 1. Compute how much water it can trap after raining. So if we just look at this right here. So looking at the image again, we go from 2. We're not going to know what our water level is until we reach the 3.
Yep, agreed.
And so we're going to have to work backwards. And so we'll start working backwards from this 3. We'll see a 1, 0, a 1, and a 2. Trying to figure out why we would stop looking backwards. I mean, unless we run into something higher than our 3, or we reach the end, or we go down again. So we reach this 2, but then it goes down again. So we stop, calculate this. Okay, I'm just going to try and run through this.
Sure, go for it. I think that would be helpful.
We start at 3. Go to 1. So difference of 2. 1, 0, 1, 1. So we went down 2 and another 1. We went up 2.
Makes sense so far.
And we also need to know the distance that we're going, which is just the number of numbers. We would kind of need an ID of some sort to keep track of that. And so I guess we'll start that here at 0, 1, 2, 3. So we need to track as we move along so that we can get the distance between the two, as well as the total level. So from 3 to 1, nothing really happens. We move down 2, move down 1. Nothing happens until we start to move up. So now we've moved up 1. And if we look back, zero to 1. So as we go down and up, so do I really even need to pass through the difference, or can I just pass through the level? Let's try that for a second.
Yeah, go for it.
Which level we're ending on. So one, 0, 1, 2. Okay. So we could maintain a slate as we're recursing and look for matches between two levels and how long it was between them. And in this case, we go from one level to another level. It only had one step in between, so it would give us one block. Now, I guess this is kind of redundant, but we started somewhere. So we've got 3 to 1, nothing really happens there, from 1 to 0, and from 0 back up to 1. And so from 1 to 1, we've got one block of water. And then when 1 goes back up to 2, we've already counted the block between these two, so we don't care about that anymore. All we care about is from this 2 backwards. So look from the 2 back to a number that's it or greater, back to this 3. And there's 1, 2, 3 blocks in between it. And so that equals 3 more blocks of water. Okay.
So could you walk me through really quickly just what the high level of your solution so far is?
Yeah. So we need to iterate through this. Starting from, I guess, either end, it doesn't really matter. And we're looking for, like say, looking at this picture over here, you get up to 1, and then you go back down. And you get up to any number that's greater than that 1, and that means you've got 1 block of water stored, or however many blocks are in between those two numbers. And so, and then you go back up. And then when you get to this next area, you go down, and nothing happens because you don't know where your endpoint is. You go down one more time, and then you go up. And once you go up, you notice, you look back and see where it matches. So any number that is equal to the level you're at or greater, and that comes right back to this other block, and you count the blocks in between, and that is how many blocks of water you've got. Then you go up a layer again, and this one goes up to 3, and so you just look backwards, and the next highest is 2, and there's nothing higher than 2. It's looking too far though. And you count the number of blocks between. I guess that's kind of the brute force approach to this. And then you don't have.
Yeah, the only thing I would be concerned about is how are you sort of doing this mechanism of looking back? So if you see that you're, say, at the 3 pillar, what are you referencing to find the 2 pillar? Like that the last height was 2.
Yeah. And that's kind of what I'm trying to figure out, is how to structure this as code, or as a recursive problem or a tree. So as we move along, we have to store where we currently are, or we just need the index to where we are.
Mm-hmm.
And so when we get to this number and we're looking backwards, we can just start at the index we're at, and we can look backwards. The problem with that is that's going to be, that is brute force, because you could potentially go up a step every level and you'll always be looking back. But we don't care about that for now. Let's get a solution. And so we just use the index. So say we're moving through this example right here.
Mm-hmm.
And we come at this 2, which is index 0, move down to 1, move down to 0, get to 1, which is 1, 2, index number 3. And we notice that we've gone up from 0 to 1. And so we look backwards for a 1 or greater. Just looking at the previous index positions. Actually, so as we move along, we could just store the nodes in a slate. As we move down, we get to 2, we put 2 in our array. Move down to 1, we put 1 in an array, move down to 0, and put that 0 in an array, same array. Move up to 1, 1 is greater than 0, we pop 0 off the array. We pop off the array until we get back to a 1. So I guess, we could try and do this a couple ways. We could try and look it up, but that would most likely be suboptimal in time.
Makes sense. I would agree.
Or we could just keep track of the levels that we came from. I guess that would, an array that would look pretty much like this. And say when we got to this 0, we would add it. When we got to this 1, we would, and so let's just look at it at that point. And we would have 2, 2, 1, 0. And we're currently at 1. And so we would pop this 0 off. So we would be at 2, 1. And we would keep track, if there was more than one number here, so how many items there were in between those 2, until we reach that 1. And we could add that to our total units of water.
Interesting. I see.
So
how would you assess the time complexity of that solution then?
It would be the same. It would still be, well, if you had a worst case scenario input, then that would be Essentially, you could be looking at popping every node. No, that is a little better. Sorry, I'll admit that time complexity is not my greatest strength right now.
No worries. Always good to work on. So what do you think would be better?
I think keeping track of it like this would probably be better.
Mm-hmm.
But it might just be the same.
Sure, makes sense. So I think what might be causing you difficulty right now is that whether you're starting from, I think you're right that it doesn't matter whether you start from the start or the end. So let's just say you're starting from the start for simplicity, because it's the same problem either direction.
Yeah.
The problem is that with that one pass, you're not able to look up what the previous value is, or the previous, the previous largest hill, or whatever it is. So I think looking into a different way to traverse is probably more important here than looking for a more elegant data structure.
Yeah.
I don't think there's a data structure that's going to give you the information that you need to be able to store that.
Yeah.
So I think you're on the right track with sort of the checking that you're doing. Looking when we move down, watch for when we move back up, things like that. You're just not, the way you're traversing currently doesn't give you the right information you need.
Okay. So let's just get rid of this and go back to the basics of how we're going to traverse this. We're going to start from the beginning, and we're going to look at this first node. And if we go with the recursive strategy of lazy managers, we're going to take one and pass the rest on. And we'll need to pass down our index position as well as some kind of state. Which I guess is kind of what I was trying to figure out as far as data structure goes, but I'm getting stuck on that. So we just continue to do that and pass, take one off and pass it down. And I'll admit I'm having a very hard time describing my thought process here.
No worries.
I think I have a basic idea of how to code for this.
Sure, I would say at this point just to go for it.
Okay. And I realize that coding before you're ready can often waste time, but I don't think I'm going to get any farther in the design phase at this point without writing something. So
yeah, definitely, it can often be helpful. It's a balance.
Yep. So we've got okay. So I guess we first need a base case. I guess one of the problems that I'm having is I keep looking at this as an iterative problem instead of a recursive problem. What are the constraints for input and output, like maximum number of points I'm going to be given?
I wouldn't worry about it too much. It's not going to be anything concerningly large.
Okay.
Full disclosure, I have like 2 other input cases, and they're both roughly the same size.
Okay.
But no need to worry about it. I will say, I think what you're probably going to need for doing this as a recursive solution, because it is true that you can do it as multiple ways. I think you're going to need a fair number more inputs to your helper function.
Yeah. Okay. Sorry, I'm just thinking. We've only got about 20 minutes left, or 15 minutes left, don't we?
That is about right. I'm happy to jump in with a little bit more input if you want.
Okay. I'm stuck. I think I need some hints.
No worries at all. So kind of what I was leading you towards before, with the way of traversing the array is, and I think you almost hit on this pretty well. You're essentially going to need to do this in 2 directions. So what your, the overall goal of your helper function here is going to be to not just be able to traverse it in 1 direction, but essentially to be able to traverse it in 2. Basically, the things you're going to be looking at are both the left maximum, so that whatever your current left pillar is, as well as the right maximum, so whatever your right pillar is. And yeah, essentially you're going to be looking at that local left max and the local right max, as well as kind of having a 2-pointer solution to it, if you want to think about it that way.
Okay, so I'm going to be looking at this. Sorry. On the way down and the way up, as far as the recursion tree goes.
You exactly got it.
So index, Lmax. And so let's give this a try. We're going to start at 0. Our index, our Lmax is going to also be 0. And we're not going to know what our Rmax is. As far as a base case, when we get to the end, we're done. So if index is equal to length of array,
I guess also to provide one more bit of insight here. So you're not just going to want a single index necessarily. For this, you're going to be wanting to both, go from essentially the left and the right. So you're going to need to develop this with 2 indexes in mind to your recursive function.
Okay.
So imagine going from left to right as well as right to left. And then your recursion is kind of closing those 2 pointers in on each other.
Okay, so we're literally recursing from both ends. Well,
Yeah.
not recursing from both ends, but...
Mm-hmm. So when you were saying that you can go from the start to the end or the end to the start, you actually do want to do both.
Okay, then this is not going to end at that point. This is going to end when LP greater than or equal to RP. What did I just do? Nope. This is making me feel like I was not prepared.
No worries. This is a particularly tricky one.
Yeah. All right. So looking from that strategy of moving from both sides, I'm going to want to move both pointers. So helper pointer, right pointer. So if I think about that way for a second, I start here, I start here, I look in between, I'm going up in both directions. There's nothing to see. So I move on to the second spot. It's not going to matter what the right pointer is until I get to here. All right, I'll be totally honest. I'm completely lost on this.
No worries. I'm happy to kind of provide, I guess, the last couple of points that you'll need here. So essentially, you have the local max on the left, local max on the right. You have the left pointer and the right pointer, and now the only parameter you're missing to your helper function is going to be the total area. So you're going to store that total area as one of the arguments, and then each recursive call, essentially what you're going to be doing is calling helper again, but with these arguments changed. And then when you reach a certain condition, that essentially means I'm done traversing now. Then you're going to return the output of that total area.
Okay.
So I think you already got the, if the left pointer is greater than the right pointer, you've gotten to the end. Now you can return total area, and that's going to be your return, or you can return total, as it were.
Okay. So what I meant was, I understand what you mean by the right pointer and the left pointer and having an Lmax and an Rmax. Yep. I'm not sure how to implement the logic that counts it using that information.
Yeah, it makes sense. So,
yeah.
Yeah, so it's kind of going to be a let me think about how to explain this best. So obviously you're going to be making a choice between, at any step, whether to move the left area or whether to move the left pointer inwards or the right pointer inwards. So that's essentially going to be a decision based on what your left max and right max are. So I guess just to give it for now, if the height at the left max is less than the height at the right max, you're going to want to move the left max in. So you know how we were talking about the difference between the 3 and the 2? It's essentially going to be the same thing as that, where you're looking at, if you had one wall that was 8 tall, this is a little hard to do without a diagram, but if you had something here, let me write this out. So if you had something that looked kind of like, let's say it looked like 3, 2, 1, and then 5, 8. So if you start from this, this is going to be a situation in which, you're going to be able to, if you started your left at the leftmost position, the right at the rightmost position, and since you're starting there, those are your maxes. You can see that the left max, or sorry, the right max is greater than the left max in this case. So you're going to want to move that right pointer in.
Okay.
Yeah. Because there is no additional rainwater being trapped by this 8 pillar. So you're not quite sure of that yet.
All right, that makes sense.
Yeah.
I guess what I'm not understanding is, say you've got a 1 over here. Is your Rmax would be starting at this 1, wouldn't it?
Yeah, it would indeed. So the left max would in fact be taller than your
Rmax.
Than your Rmax, yeah.
And so you would move your left pointer in.
Mm-hmm. So you would there is additional logic you would have to do within there at each step. That would essentially be taking account of it. Roughly what that would look like is, saying, you're going to first or last, either way, increment the left pointer, and then you're actually going to compare the left pivot to your left height. And you're going to ask yourself if we set a new maximum or not. So
Gotcha.
if we went 3 or 1 here, essentially what you're going to be looking at is, let's say there's a case where it's 8 instead. If you go from 3 to 8, you're not going to be adding any height. You know that you just went up, essentially. So you're not going to be adding any water here. But if you go from 3 to 2, instead, what you're going to be looking at doing is you're going to add the water height of whatever you decremented by. So this is the logic that you designed in the beginning. Once you dip down, you add in that difference.
Yeah.
Yeah. So if you dropped from 3 to 0 here, you would add 3. If you drop from 3 to 1, you would add 2. And essentially that's how that works. And you know that you're not going to, you know that this is going to pool water. Let's say it dropped from 3 to 0. You know that the 0 is going to pool at least 3 because you already did the check previously that you are in, this sort of water pool, if you will. So you know that the water level is at least 3.
Okay.
Yeah.
All right. So knowing all that, I think I can get it to work from one direction. Basically, we're checking if our left pointer is greater than our right pointer. And let's do it the other way. It's easier for my mind. The left pointer is less than our right pointer.
Mm-hmm.
Then we want to decrement our right pointer because it's too big. And like you were saying, move down from that 8 to that 5. If no, I don't even need that. We can just do an else. So if our left pointer is greater than our right pointer, then we're going to move our left pointer. So, and add to the total. And I think this might have worked as well to track the total, but
yeah, I believe with the nature of the recursion, it would have actually.
Yeah. And so we're going to say total plus equals the difference between left pointer Only problem I see with this is if it goes up, if we decrement our left pointer, and this is a bigger number, and we just added the negative number, so we don't want to do that. So we do have to check. Or we do this at the next iteration. So I'm sorry, Anthony. I am feeling very hopelessly lost,
No worries.
and I don't want to waste your time.
It is absolutely not a waste. I'm more than happy to either give you a couple more minutes if you wanted to continue working, or give you some initial feedback and provide some space for questions if you rather do that.
I think at this point I'd rather do that. I don't see myself solving this problem, and at this point I've had so many hints that it wouldn't matter too much anyway.
No worries at all. Yeah, totally happy to provide a little bit of feedback then. So yeah, just overall, I guess starting off, good job on getting through the problem. This is definitely a more difficult recursion problem, I would say. There tend to be only two kinds of, the really recursion focused problems, which tend to be either the extremely close to formula ones, things that are mostly just knapsack variations, or there's also, knapsack, Fibonacci, FizzBuzz, that general class of things.
Yeah.
And then there's sort of multiple possible solution problems with a recursive solution, which is more what this is. So I opted for the more difficult one just because I think, I think generally, one, companies tend to ask the more difficult prompts, especially on on-sites. And two, the more difficult ones generally sort of give you more insight into the interviewee's thought process. So that's kind of the process behind that. And yeah, definitely no worries about being, having to struggle a little bit with this one. This is a difficult, problem conceptually. But
Yeah.
with all that said, I think the strengths here were definitely that your communication, when I did ask for explanations, was really on point. It felt pretty easy to follow along with, kind of whatever solution you were talking about. For example, when you explained in the beginning, your initial solution of doing a post order traversal, going from back to front, and then counting the difference between the levels, that was totally clear and made complete sense. And then other strengths, I think that on the broad level, I know I know that you said you didn't respond super well to hints, but I actually think you did. At least to the level of when I did give hints, you were able to process them and kind of at least find the one next logical step, if not going all the way there. It also generally just tends to be the case that if you're pretty far into the hints, they start to get more and more difficult to grasp just because of the nature of the problem. If you weren't fully, convinced of the initial hint, then 3 hints later is bound to be just confusing anyway.
Yep. And I think something else that might have been going on was the hints that you gave me were so far off from the way that I had viewed solving the problem that they were harder for me to follow.
Yeah, exactly. That totally happens. Unavoidable to an extent, but yeah. Other than that, I think areas where you could have improved just off the bat, I think, are in the design phase. Obviously, I think there is a little bit of a conceptual gap where it was spotting the sort of two-directional traversal earlier. Obviously, would have been the route to success. But there's no way to super well train for those kind of niche cases. So I would say what is a little bit easier to train, that is a practical thing that you can work on, is just kind of working on the way you work through problems, if that makes sense.
Yeah, it does.
At least from a communicative standpoint, I think you tended to struggle with it by yourself for a good chunk of time, and then come back to report, and then struggle with it for a good chunk of time, and then come back to report. Which is, I think the intuitive approach to interviews. But I think what helps a lot of people kind of find their groove with interviews is instead going for presenting every part of your thought process. So kind of doing almost a logic proof style. Well, I know this fact about this problem, then that means this, then that means this, then that means this. And just really zooming in on each fact you can say about the problem. And that kind of helps in two ways. One, it helps you it helps you conceptualize it better and figure out where the errors are in your own logic. So, if you said, well, I need to know I need to know the max of the previous one, and I already know the max of the next one because I'm traversing in this order, eventually you would have thought maybe, oh, I could traverse in both directions and I get both. And also it just helps laying out facts in sort of that one by one way. Also really helps the interviewer kind of guide you along in a really meaningful way. Because then you give them something to point to where it's not the interviewer giving you the answer or even that big of a hint, just saying, if you're naming facts over and over again, they can kind of just point at one and be like, I don't know if that is necessarily true. What about this counterexample?
I like that.
Yeah. And those are the kind of hints that are essentially, as far as grading goes, they're free. It's a very simple, very small pointing out that something might not be true, and you as the interviewer you as the interviewee still get to completely take credit essentially for whatever comes out of it.
Yeah, that makes sense.
So yeah, that would be my big. Sorry, I realized that was a bit of a ramble, but I hope that made sense.
No, it did. I appreciate that.
Yeah, that's kind of my big tip for getting through the design phase. But that would be the main point of criticism I would have there. Other than that, I think you did pretty well. Obviously, we didn't get to a ton of coding, but from what I saw, you all structured in a reasonable way, and saw the basic structures of recursive algorithms. So no complaints there. No super specific technical topics I would focus in on. But yeah. So we had about 4 minutes left. I'll have more detailed feedback for you when I submit the feedback sheet, but wanted to know if you had any questions for me before we dropped off.
Not really any questions right off the bat. I feel like my biggest weakness in this interview was that I didn't understand recursion enough to be able to see this as a recursive problem in my head.
Mm-hmm. Yeah, no, it's definitely a tricky one.
I do have one question that's completely unrelated to this.
Absolutely.
So when I'm writing resumes, I always struggle with the education section because I'm completely self-taught. What would you advise putting in the education section?
Generally,
2 years or? Sorry, go ahead.
Yeah, I would say honestly, just don't include it. Just include, projects or any other credentials that you would have. I think generally we live in a space that's more or less, you don't need the education section unless it doesn't really help unless you're from a particularly prestige, university or degree. Just having a degree is kind of a substitute for having gotten the experience elsewhere. I can't say in your particular case, but I would say to try to, assemble some good side projects, assemble some good, maybe open source contributions or really anything else. And just fill it with that instead of an education section.
Cool. So if I've got, 2 to 4 years of work history at software companies, then it's not really as big of an issue.
Yeah, sure. I think there's plenty of other resume sections that you can fill in. You could get some certifications. You could just honestly just list some skills you have. Yeah, I would say just not to include it.
All right. Thank you for your time.
So much as well. Yeah, like I said, I'll try to get that feedback to you within 1 or 2 days now. And beyond that, you have my email as well. It's tied to it's sent the email that was for the scheduling to me as well. So feel free to reach out to me there. If you have any other questions, either about this interview or just the interview process in the general. And I'd be happy to help there.
Thank you so much.
Awesome. Thank you so much as well. Have a good rest of your day.
You too. Bye.